Hey everyone, in this video we're going to go through how to use a calculator to determine normal probabilities or properties, because we could work out the probability, but we could also work out what our x value is or our z value. So we're looking at different properties of the normal distribution. So the reason I'm doing a video is because there's a lot of calculator work. I have put the calculator steps into the PowerPoint, as you can see. They're just taken straight from your textbook, but remember I printed them for you so you have a copy. Make sure it is in your bound book, although it isn't really that difficult to do it on the calculator, but still a good idea to have the steps there just in case. All right, so I'm going to try to make this less than 30 minutes long because I've got to take my son to basketball. So let's see how we go. We'll get started. All right, so this question here, we're looking at the standard normal distribution, which we're very familiar with, and we know based on our percentages that one standard deviation either side is going to give us 68%. So for question A, we're basically looking at one standard deviation either side of the mean, which is 68%. Now, it's only approximate. All right, so that 68% is only approximate, the 95% is only approximate, and the 99.7% is only approximate. So if we want the actual values on our calculator, and I've done them before, but I'll show you again where to go. So interactive, distribution, and continuous, because remember the normal distribution is a continuous function. All right, and we want normal CDF. Okay, because we're looking at a range of values. So our lower limit is -1. So I should say my lower limit. I'm going from 1, z equals -1 to z equals 1. And because it's a standard normal distribution, my standard deviation is 1 and my mean is 0. So that's kind of like the default in the calculator. So if you're working with your standard normal distribution, it already has it in there. But if it's just the normal distribution, then you'll have to put in your standard deviation and mean. Just take note that they ask for the standard deviation first and then the mean. All right, put that in and you can see that it's approximately 68%. It's there as a decimal, but we can multiply that by 100 to turn that into a into a fraction, which isn't as nice. Let's do that again. All right, so you can see there 68.2689, blah, blah, blah. So it's just an approximate, the 68%, but we can see there that, if we're doing it exactly, there it is. And we're going to get the same thing if we did -2 to 2. So let's just quickly do that. So we're expecting around 95%. All right, so our lower limit, z equals -2, upper is 2. And the standard deviation is 1, mean is 0. So there you go. You can see it's going to be 95%. And we're getting roughly 99.7% for C. All right, so that's just using your normal function on your calculator. All right, let's have a look at question 4. So here we're looking at different probabilities. Now in methods, we don't really follow the 68, 95, 99.7. Because that's an approximation, we get the exact values. So all these, actually not all of them, the first one you could get using your percentages, but as soon as you start working with different values, so like this -1.5, you couldn't approximate it because it's the way the curve is, it's not like a rectangle, it's a curve, so the area does change. All right, so we do exactly the same thing, going to interactive, distribution, continuous, normal CDF. So for the first one, we're going from 2 to 3. Now it is a standard normal. It does say standard normal in the question, but it also has Z. All right, so the Z is a giveaway for the standard normal distribution. All right, and there you can see if we, that's a probability. If you need to do it as a percentage, you just multiply it by 100, but often it's just left as a decimal. All right, and you can do the same for the others. So if we were to look at B, all right, continuous normal CDF, we're going from -1.5 to 2.5. And standard normal, so it's 1 and 0 again. All right, and there you go. Same for the other two, so I'm not going to follow those steps for those two. So hopefully you know now how to put that into your calculator. Now, also the calculator, if we does the reverse, so we call it the inverse. So the inverse normal. So this time we've been given the area or the probability. So for the first one, the probability that Z is less than or equal to C is equal to 0.1. Remember, with continuous probability, of which the normal probability is a part of, it doesn't matter about your inequality sign, but it does for discrete. So here it doesn't matter that it's equal to. All right, so on my calculator, we're just going somewhere a little bit different. Still pretty much the same spot though, but instead of going to continuous, we go to inverse. So the inverse is now just going to tell us, tell us what that value of C is. So I should have drawn a diagram first. Let me draw a diagram first. It does say to draw a diagram and then find it. It's just really hard. Oh, I nearly knocked my water off. It's really hard to draw on this screen. So if we've got a normal distribution, and it's a standard normal, so I know 0, 1, 2, 3, and -1, -2, -3. So we have I don't like that highlighter. I like these pretty colors. All right, we've got a probability of 0.1, and Z has to be less than C, so that is quite a low number. So it means C is going to be down this end. I don't know where, but I know because it's such a low probability, it's less than 0.5, it's going to be in this corner here. All right, if it was greater, then it would be on the other side. So that does help. It does help to draw it because on our calculator, it's going to ask for, so inverse normal CDF. It's going to ask where your tail is. So this is to the left, to the left, to the left. All right, so your probability, we're going to put in 0.1. All right, and it is a standard normal, so we can leave it as 1 and 0. It just happens to be these are all standard normals, but you can have just a general normal distribution and you just change the standard deviation and the mean. All right, now we would expect something below 0. Okay, so I've got -1.28, okay, because it's on the left side of 0 and it's a standard normal distribution. So that makes sense to me. If I did it the wrong way around, so let's say I went in and did change this to the right and did 0.1. Oops, why didn't you work? All right, it's going to be down the other end of our normal distribution. All right, so you can see there at 1.28. So it's basically looking at this area. So remember they're symmetrical. All right, but we want less than C, so it's this area here. So Z is less than or equal to, what was it, -1.28, I think. Let's just go back to my calculator. -1.28. All right, so for question 11, let's draw our normal distribution again. So that was question 10. Do question 11 over here. Okay. I just realized I didn't save this, so this is going all over my PowerPoint. All right, so it's a standard normal again. You probably don't even need to put these in. But while you're learning about the normal distribution, it might be a good idea to do so. All right, so this time we have Z is less than C is 0.25. So that is very, very small. All right, very small probability. So it's going to be down here somewhere. All right, so C is going to be somewhere around here. Okay, just like it was here. All right, but we can just do that on the calculator. Or the only thing we need to know is that it's on the left side. So if you drawing it just helps you make sure you don't do the wrong one. All right, to the left, to the left, to the left. All right, 0 to 5, and it's a standard normal, so it stays as 1 and 0. Come on. All right, and there you can see, oh, it's a little bit more. It's my bad. Didn't really draw it that well. But it doesn't matter, the calculator's doing it for me. So negative 1 point, and that's about 96, so negative 1.96. So C is equal to negative 1.96. All right, so we've gone through how to find the probabilities here. It doesn't matter what your values are. You can just put them straight into your calculator. You wouldn't be expected to do these by hand either. So this sort of thing you need to do on your calculator. The only thing that you'll do by hand is the questions we did today. So today being the day we did the VCAR questions and looked at the symmetry properties. Here we use the inverse normal. So if you're looking for, so you're given the probability, but you're looking at what that upper limit is or the lower limit is. All right. So here we've now got just a normal distribution. So you can see there's no reference to standard normal distribution, and we're using X. So that's a bit of a giveaway that it's not the standard normal distribution, and it's also told us what the mean and the standard deviation are. So if we're looking at X is less than 26, so if you draw your normal distribution, which you don't have to, but I'll just draw it quickly for A. All right, so there's our normal distribution, 22 is here, and we've got a standard deviation of 7. So I'm going to go up by 7. And then down by 7 on this side. Oh, it's terrible. There we go, that's better. All right, so X is less than 26. So I know, so that's this probability here. So I know it has to be just a little bit more than 50%. All right, or 0.5. I don't know exactly what it's going to be, but as long as it's above 0.5, I know I'm on the right track. All right, it's pretty easy to do on the calculator anyway. So we're just going back to continuous normal CDF because we're just calculating the probability, and I don't know what happened there, so let's try it again. Okay, now our lower limit, it hasn't given us a lower limit. Now your normal distribution does go on to negative infinity and infinity, so we can actually put negative infinity into our calculator. So there's your infinity sign, and our upper limit is 26. All right, this time it's not a standard normal distribution, so our standard deviation is 7. Just make sure you get them around the right way. Your answer will be weird if you did do it. I'm pretty sure it will be weird if you did it around the wrong way. This is why you should always think about your answer before you do your calculations. All right, so there I can see it's above 0.5, which is what I expected. So 0.7161 if you want to do it to 4 decimal places. For the next one, similar question, but our lower limit is going to be 25. So you can just go up here and change that to a 27, and we're going from 25. So you can just change it there, and there you are. So, oh, no, that's all right. Sorry. I was just thinking. So it's quite a small area. So we're only going from 25 to 27. That's why it's quite a small probability. Now for C, it's a conditional probability formula. So let me just get rid of the calculator. All right. So we want, oops, what am I doing? Oh, I was trying to draw on my mouse pad, not on the screen. Silly, silly. Okay, so it's a conditional probability. So we want the probability that X is less than 26 and X is, let me just change that because I forgot to look before I started writing. X is between 25 and 27. All over the probability that X is between 25 and 27. Now, if you're ever unsure, you just draw a number line. So for the first one, X is less than 26. Doesn't matter whether it's included or not. And the next one is from 25 to 27. All right, so what do they have in common? They have in common from 25 to 26. All right, so you can see that on your number line. All right, so where do they overlap? They're overlapping there. So we want to basically do the probability that x is between 25 and 26 over the probability that x is between 25 and 27. All right, and I'm just going to do that on the calculator. All right, so we already did 25, 27, which is here. All right, I'm just going to drag this down instead of going back to the menu, because the only thing I need to change is this 27 to 26. All right, so that's going to be my numerator. And just do as many decimal places as you can over my denominator. And there you go, so 0.52036. So probably rounding it to 4 decimal places. Right, I'm running out of room on my PowerPoint, or on this slide. So the next one, we're working out what this value of C is. So that's a hint to me that it's the inverse normal. So I'm going interactive, inverse, then inverse normal. All right, we want less than C, and it's quite a high probability. So it's less than, so it's still looking at the left side. So if I just draw here, so you're looking at basically the majority. So C is going to be, I don't know, somewhere there. I always draw it incorrectly, but I know roughly where it should be. All right, the probability is 0.95, and our standard deviation is 7, and the mean is 22. So I've got 30, oh, not far off, so 33.5139, whatever, however many decimal places it needs to be. It doesn't have to, they don't have to be whole numbers either, because we're not looking at discrete probability, we're looking at continuous probability. So you should be told how many decimal places to do that too. All right, the next one, now we want k is greater than, so we are now looking at the right side. Where are we? Inverse, inverse normal, so we'll change this to the right. All right, our probability is 0.9, and our standard deviation is 7, and our mean is 22. All right, so there you can see 13.0291, blah, 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 blah. All right, for the last one, I just had to quickly check it on the calculator. So this time we're looking at x being between 2 values. So I'll just show you what I mean on here. So it's 95%. So we know it's going to be roughly 2 standard deviations either side of the mean. So we're looking basically at this area in here is 0.95. So this is your C1 and this is your C2. So we need to find that C1 and C2. So going on to the calculator. Now you may have noticed when we did the inverse normal before, we could do left or right, or you could also do center. All right, because the probability is in the center, so x is between 2 values, that's why we're using center here. So 0.95, standard deviation is 7, and your mean is 22. Now what this gives you is your first C value. So let me just write that here. So C1 doesn't stay up long enough, 8.28. And then we've got to find C2. Now that 8.28 is, say, here. So we need to work out basically this distance and then add it to the 22. All right, so we just do 22 minus what we had to work out the distance between the mean and 8.28. So minus, it's a bit easier if it was normal. All right, so that's the how many standard deviations we're away from the mean. So 13, sorry, not standard deviations. That's the distance from the mean. It's not the number of standard deviations, sorry. It's the distance from the mean. And then we add that to the 22. So basically this distance here, let me just, so this distance here is your 13, I think it was 13.7. Let me draw that in black. So that was your 13.7, which is the same as this distance here. So we got to work out what the C2 is, because that is on the other side. So we just add the 13.7 to 22 and we get 35.72. All right, so a little bit harder when you're looking at the center. All right, let's move on. I'm just conscious of time. All right, so now we're looking at some questions from 16D. So 16D is just more worded problems, stuff that you should be able to do. So the results of a mathematics exam are normally distributed with a mean of 50 and a standard deviation of 70. Sorry, not 70, 7. When you're writing a normal distribution, actually I can't remember if the standard deviation comes first and then the mean. Actually, I might not write the notation because I might write it around the wrong way. So just when we do the binomial, so remember we do x is a binomial, so we can do x is a normal, but I'm just thinking, I think the standard deviation comes first and then the mean, but it could be the mean and then the standard deviation. Anyway, I was going to write that just so I could highlight it, but I'll just highlight it. Actually highlight it. What is the probability that a student chosen at random has an exam mark greater than 60 and then less than 75? And then we've got this, given that, remember that is your conditional probability. All right, so let's do the first one. So greater than, so we're just looking for probabilities, so it's just distribution, continuous, normal CDF. So we want greater than 60, so 60 is our lower limit and infinity is just going to be our upper limit. Our standard deviation is 7 and our mean, we can't see, what is that, 50? All right, so there it is, 0.07656, blah, blah, blah. Less than 75, so we just go back. All right, so this time our lower limit is negative infinity. Our upper limit is 75. And our standard deviation is 7. I don't know why I keep saying 70. And our mean is 50. All right, so there we go. So you can see the majority of people are less than 75 on the exam. So 75 must be like the highest mark. All right, the part 3 is conditional probability. All right, so we want the probability that x is greater than 60, given that they passed, given that x was greater than 50. All right, so that's where we need to look at where they have the intersection. Over x is greater than 50. All right, so just drawing a quick number line. So we've got x is greater than 60 and then x is greater than 50. So what they have in common is x is greater than 60. Whoops, rushing now. Got to take my son to basketball. All right, so we can easily just do that on the calculator. So I already did greater than 60, so I'm just going to take that down and change that 60 to 50. And just make sure you get it around the right way. So we want greater than 60 on our numerator, divided by 0.5. We didn't need to drag that down, but all right, so there we go, 0.1531. All right, the top 15% of the class are to be awarded a distinction. What mark would be required to gain a distinction in this exam? So the top 15%. So if we were looking at the top, we're looking at the right. So inverse normal, and we're looking at the right. And we want the top 15%, so 0.15. And the mean of 50, and oops, around the wrong way, standard deviation, and then a mean of 50. All right, so 57 or above would get a distinction. All right, last question. The height of a certain population of adult males is normally distributed with a mean of 176 centimetres and a standard deviation of 7. Find the probability that the height of a randomly selected male will exceed 190. So going back onto my calculator, all right, inverse. See, it's just so repetitive. The lower limit, what was it, 190? 190 will exceed. So exceeds means needs to be above. Now, obviously you won't have a height of infinity, but your area as you get beyond 3 standard deviations is very low anyway. All right, standard deviation of 7, 176 is our mean. All right, so there you go. If 2 males are selected at random, find the probability of their heights will exceed 190 centimetres. If we've got one male the probability of a male being greater than 190 centimetres is 0.022275. So if we want 2, we're just going to be multiplying that by itself. All right, so you can see there I've just squared it. When I did that before, I got the E, so you can either interpret that, or if you're still getting that on your calculator, just change it and make sure your number format is normal too, and then you should see all your decimal places. So it's the probability is quite low to get 2 people at random to be over 190 centimetres tall. All right, part C, suppose 10 males are selected at random. Find the probability that at least 2 will have heights that exceed 190 centimetres. So this question is actually the binomial distribution with using the normal distribution. So we're now, let me just highlight this. So we've got 10 males, so our number of trials is 10, and we want at least 2. All right, exceed 190 centimetres. So it's a little bit tricky because we're doing normal distribution, but you can find your probabilities in a continuous environment, I guess. So we're looking at heights that can be measured, but that's giving us our probability. Now we're looking at selecting a number of males. So if we've got 10 males, how many of them, if we've got 10 males, what's the probability that at least 2 of them will have a height that exceeds 190 centimetres? So now we're looking at the binomial distribution, and I'm not going to use, I could use X because X hasn't been used before, but I might use Y just because we may have used X to do the normal distribution. So here we've got n equals 10, and our probability of success, what was it? What did we get? 0.02275. 0.2275. All right, just double check that I wrote that correct. I'll be using the value from the calculator anyway. All right, so we want to have that between at least 2, and because it's now binomial, it's discrete, we have to be exact. So at least 2, and the maximum can be 10, all right, because we've only got 10 males. All right, can't be done other than on the calculator, so let's go to binomial. So discrete, binomial, CDF. So our lower limit is 2, our upper limit is 10, the number of trials is 10, the probability of success, I probably should have copied it. Oh, sorry, I'm going to copy it. All right, so let's just copy that, go through it again. My son just messaged me, he's probably like, Mum, hurry up, I need to go to basketball. All right, just make sure I've done the whole thing, there we go. All right, so the probability is 0.0206. So quite a low probability. So just think you're maybe going to the football and you just pick out 10 males at random. What's the probability that at least 2 of them will be greater than 190 centimeters. So you think that's would be quite low. All right, 190 centimeters is like Mr. Blackshaw high. So it's very rare. So that's why you've got quite a low probability. All right, that's all you need to know for your calculator. I made it 30 minutes. Fantastic. All right, girls, see ya.